Well, welcome. In this video, we're going to be completing the second half of Lesson 11.4. If you recall from the first half of the lesson, what we were doing is we were taking an equation in standard form, getting it down to factored form, and then using those factors to find the zeros or the roots of the polynomial. In this lesson, we're going to work our way backwards. What we're going to do is we're going to start out with the factored form and then expand it out into the standard form of the polynomial. So you can see what the original equation would have been, that would have been graphed, that would give us those zeros or those roots of that polynomial, again in standard form. So this is going to require a little bit more work, a little bit more algebra and some multiplying of some polynomials together. So you want to make sure that you have some patience with this, but it's really not that difficult. So with that, let's go ahead and just jump into things by looking at these examples here. So in these examples, we're going to be looking at writing a polynomial when we know the zeros. Before we look at this example, though, it's really important that we remember from the factor theorem that x minus r is a factor of the polynomial as long as r is a 0. So when they give us these zeros, negative 2, 3, and 4, we can write the factors as x minus each of those zeros. Now remember, minus a negative becomes a positive, so when I do this first one, x minus negative 2 becomes x plus 2. So that's one of the factors of the polynomial, again, because of using the factor theorem. X minus 3 would also be a factor of the polynomial, as well as x minus 4. Because if we were to set each of those factors equal to 0, we'd end up getting our zeros of negative 2, 3, and 4. So our goal is to get our equation to be in standard form. So we're going to go and multiply these together. Now you can use any method you choose. Personally, I like just using this box method, not the Xbox method, the box method, where we create our box. And then we're going to set these factors. Now it doesn't matter which two I multiply first. If I want to put the x plus 2 and x minus 3, if I want to do that first, I could. We put those factors on the outside of the box, then we're going to multiply these together to get it in standard form. Now we're going to have to do this in a couple of parts. So again, we can't multiply all three of these at once. I mean, there is a way we could, but it gets really complicated. I think it's easier if we do this in two separate parts. So let's start by multiplying these together. So when you multiply x times x, we get x squared. X times 2 would be a positive 2x. Negative 3 times x is negative 3x. Negative 3 times 2 is negative 6. So when I multiply just these first two, I end up getting x squared. Now, negative 3x plus 2x is negative 1x, or just minus x minus 6. Now I still have to multiply that times the x minus 4. So now I'm going to create a box that's a 2 by 3 grid. And on the side that's got the 2, I'm going to put the two terms, x minus 4. On the side where we have the 3 columns, I'm going to have the x squared minus x minus 6. Now when we multiply these together, we get x cubed. This would be minus x squared. And then this would be minus 6x. Then minus 4x squared. This would be a plus 4x. And this would be a positive 24. So now when I combine like terms, we get our final answer in standard form. It'll be x cubed. There's no other x cubed, so that stays the same. The minus 4x squared and minus x squared, though, those combine to be minus 5x squared. And then the negative 6x plus 4x is negative 2x. And then we have the plus 24. So our equation, we can say, would be y equals x cubed minus 5x squared minus 2x plus 24. And that's it. So again, the key here is you start by just putting the zeros into factored form, and then from factored form, multiply pieces together to get your answer in standard form. Let's start by looking at the next one together, and then I'll have you multiply it together on your own. But here we have one of the zeros is just 0. Well, if I put it in factored form, x minus 0 is just x. Then we would have x plus 5, and then we would have x minus 6. So you can multiply this in any order that you want. If you want to multiply these two binomials together first, you can. You can distribute the x, the first binomial, and then multiply those two together. It doesn't matter to me personally. You might want to just multiply the two binomials together. I don't know, whatever you choose. So why don't you pause the video and hit play when you're ready to check to see if you have the correct answer. Okay, so let's see how you did here. So what I ended up doing is I ended up multiplying the two binomials together, the x plus 5 times x minus 6. Again, if you had distributed the x through, you only want to do it to the first binomial, just the x plus 5. Don't do it to both binomials, otherwise you end up with the wrong answer. So when you multiply these together, we end up getting x squared, positive 5x. We get a negative 6x and a negative 30. So when we combine like terms, we get x squared minus x minus 30, but don't forget, we have to multiply everything by x now. And when you do that, you get your polynomial of y equals x cubed minus x squared minus 30x. So hopefully you got that as your answer. Now sometimes, instead of having the zeros given to us, they're going to instead give us a graph. Or maybe we have to graph the equation on our calculator to find the x-intercepts. Either way, we have to look at the graph and see where does it cross the x-axis at, because those are the zeros. Remember, the zeros, the roots, the x-intercepts are all referring to the same thing. So let's start there. So the zeros, again, are the x-intercepts. So we have zeros of negative 6, negative 2, negative 1, and positive 2. So next, we want to put it in factored form. So in factored form, we're going to use that factor theorem. So it'll be x minus negative 6 becomes x plus 6. X minus negative 2 becomes x plus 2. Then we'd have x minus negative 1 becomes x plus 1. And then finally, we would have x minus 2. Now, when we multiply these together, we could either do it just from left to right if you wanted to. Personally, I would group this up into pairs first, so maybe multiply the first two and the last two. Or what I noticed with this one is that these two are conjugates of each other. And if you remember that when we multiply two conjugates, something significant happens. Let's look at what happens if you forgot. So again, you want to do it, set up your box. Now if you remember what happens, you can go ahead and jump to the shortcut. But if you forgot what happens, you want to follow along. Now again, this is special because these are unique. These are conjugates of each other, x plus 2 and x minus 2. So when we multiply these, we get x squared. This will be 2x. This will be negative 2x. And then we get negative 4. And if you notice, 2x minus 2x is 0. So when we multiply these two together, we just get x squared minus 4. Now, you still want to multiply because we still have this x plus 6 and x plus 1. We're still going to multiply those together. So let's actually do that next. So we're going to take, I'll do that down here. So we're going to multiply these together now. So we'll take the x plus 6, put that on the outside of the box, and the x plus 1 and put that on the outside of the box. Oh, by the way, for going back to the conjugates, so if you didn't recognize this, the shortcut was if you multiply just the first terms and the last terms, you get your answer. X times x is x squared. 2 times negative 2 is negative 4. But that only works because they're conjugates. These are not conjugates, so we have to multiply it this way. And when we do that, we get x squared. This would be 6x. This would be a positive 1x, and then we would get 6. So when we combine like terms, don't forget about that x squared minus 4. We still have to multiply by that. But when we combine like terms, we get x squared. 6x and x together makes 7x, and then plus 6. So we are still not finished yet. Now we have to multiply these two together. So we're going to multiply these by setting up a 2 by 3 grid. So I'm going to put the x squared minus 4 out here, the x squared plus 7x plus 6, I'll put that here. And when we multiply these together, we get x to the 4th. This will be 7x cubed, and this will be 6x squared. This is negative 4x squared, negative 28x, and negative 24. So now when I combine like terms, I get my final answer of y equals x to the fourth. Now you got to be careful, we're combining like terms. Some of you might be in the habit of thinking, oh, the diagonals are always like terms. These are not. There's no other x cubed, so that stays a 7x cubed. The 6x squared and minus 4x squared, those are like terms, so together that makes 2x squared. And then the minus 28x doesn't have any other like terms, and neither does the 24. So this would be your final answer. So again, kind of a long process, nothing really that difficult about it though. So why don't you guys take a couple of minutes, and why don't you guys work on this one on your own. So here you have to count to see where your x-intercepts are. It's a little bit easier. By the way, assume that this is hitting this x-axis at this point. It's kind of hard to see that, but we're going to assume that these are all integer values for x-intercepts. So why don't you guys go ahead and do that. Figure out what these 4 x-intercepts are going to be, and then use that to find the factored form, and then write your answer in standard form. So pause the video and hit play when you're ready to check to see if you have the correct answer. Okay, so let's see how you did here. So your first step is we want to find the zeros for this by looking at those x-intercepts. So hopefully you looked at that correctly, because I could have thrown off your entire answer just by getting those wrong. But our zeros would be negative 9, 0, 8, and 15. So in factored form, you should have had, now the 0 of 0 would just be x minus 0, which we could just put as x out in front. If you had it in the middle, it doesn't matter. But this would be the best way to write it. And then you could have the x plus 9, the x minus 8, and the x minus 15, again in any order. So now what I did is I'm going to multiply these together in 2 parts, and then multiply those, what we get is these 2 parts, to get our final answer. So the x times x plus 9, that just gives me x squared plus 9x. Now the other part I'm going to do over here, and we end up getting, on the outside of our box, we put these pieces, so we get x squared minus 8x minus 15x plus 120. Combine like terms, and we get x squared minus 23x plus 120. Now we're going to multiply these together, so I'm going to set up a 2 by 3 grid. Multiply those, we get x to the fourth minus 23x cubed plus 120x squared. Now some of these are going to get rather large here. We get 9x cubed, and then negative 207x squared, and then plus 1080x. Combine like terms, we get our answer. Y equals x to the fourth minus 14x cubed minus 87x squared plus 1080x. Well, there you have it. That is lesson 11.4 completed now. So remember the first part of the lesson, we took an equation in standard form, got it to be in factored form to find the zeros. In this part of the lesson, they gave us the zeros, we got it in factored form, and then we rewrote it to be in standard form. So good luck now as you work on your assignment.